And I'm back. This is part 2 of chapter 12a. If you haven't seen part 1, watch part 1 of chapter 12a. Do not watch this video until you have seen chapter 12 part A, part 1. So we left off here talking about salvation. How is it that molecules can be pulled apart? Okay? So the molecules of solvents surround and separate the ions or molecules of solute. In other words, the solute gets jumped by the molecules of solvent and pulls it apart. Hydration is the solvation in water. So that's what water will actually do. Okay? Meeting people's physical and spiritual needs, solubility and the wisdom of God, because God's wisdom is able to take apart things in our lives that need to be taken apart. Just a thought. Okay. We got to talk about dissociation and ionization. Okay? So here, dissociation, if the solute is an ionic compound, solvent molecules break up the crystal into ions. Well, it's kind of like what I was talking about. Okay, here you have if you have your salt, here's your Na, here's your Cl, okay. The big bad water molecule comes in, here's your H, here's your O, and what happens is you get these get pulled apart, and what's happening is that they are surrounded by water molecules. That's what's going on. That's dissociation. Ionization is covalent compounds form ions when they dissolve in solution. Okay? It's kind of confusing. They're talking the same idea. They're just being picky about ionic compounds and covalent compounds. It's still the same idea about salvation. It is the big idea of how do you tear things apart? Why is it that things dissolve? And it has to do with the positive and negative charges on the molecules themselves. That's really what's going on. Okay? And sometimes, some things will dissolve, some things won't. And it's depending on how badly do they want it. Okay? And that will be another tale for another time. What in the world? I don't need that. Oh, and it conked out on me. Seriously? Okay. I'm just going to go back. I don't know what happened on that one, so I'm going to go back. I'm going to swing through. Swing through. Here we go. All right, let's go to it. So, close this. So, again, if we look at dissolving, how do things dissolve in solid and gas solutions? Pretty much it's what's called diffusion. Okay? Pretty much. And that, I will have to see what I can do about that. I might be able to demonstrate it. Okay, let's keep going. Now here's the thing. Can you dissolve just anything? It's kind of a yes and no. There are some things that will dissolve easily, some things that won't. But there is something though. Like dissolves like. That's a quick rule. Polar solvents will dissolve polar solutes. Okay? Nonpolar solvents dissolve nonpolar solutes. The no is this. Polar cannot dissolve nonpolar. Water and oil. Well, wait. What? What's going on here? Well, here's the thing. Remember, water, okay? Water has a positive and a negative side to it, okay? When you look at oil, remember we talked about polar versus non-polar. See, water, guys, is polar. Okay, it's polar because of these. Okay? Oil, on the other hand, there is no charge. There's no plus. It's non-polar. That's the idea. It's non-polar. That means there's no charge. There's nothing for the water to grab onto. Have you ever had oil in your hands and you feel how slippery it is? That's because it's non-polar. There's nothing to grab onto. This explains why water and oil don't mix, which also explains why vinegar and oil, you make that as a salad, but the vinegar is mostly water. I gotta call it like I see it, guys. All right, and I gotta keep going. So solubility. Here's the thing. Solubility has to do with how much, what's the maximum amount of solute that can dissolve in a specific solvent under specific conditions. Okay, let's think about this. How much salt can I dissolve in a cup of water at room temperature? That is solubility. How much salt can I dissolve in a cup of water at room temperature? Now, let's think about this. Somebody has a sore throat. One of the easiest remedies that's quick is you gargle salt water. I'm not a big fan of it. I don't like it. I have done it. It does help somewhat, okay? But again, how much salt can I dissolve in that glass of water at room temperature? That's the question. Is it 5 grams, 10 grams, 15 grams? How much? And that's when we talk about solubility. If something is insoluble, it doesn't dissolve, okay? It's just insoluble, period, end of story, okay? So there are things that dissolve, there are things that don't, okay? So then we have to look at saturated versus unsaturated, okay? We looked at solubility and said, what's the maximum amount of salt I can dissolve in water at room temperature? And that's when we start talking about saturated versus unsaturated. Okay? Unsaturated, you can still dissolve more solute. Saturated, you got the maximum amount of solute at a given temperature. Okay? So saturated, unsaturated, saying Canu. Wait. Come on, man. Give me something. Give me some real world chemistry, yo! Well, Cringe Master C is gonna deliver. Yeah. Gonna deliver. So here we go. I'm gonna bring the game here. You go to Cane's at lunch. You get yourself whatever Cane's meal pack and you get your cup. You go over to the soda dispenser, right? And let's say you have Coca-Cola, God's own choice, okay? So there's the Coca-Cola. There's a taste, okay? There is a taste for this Coca-Cola, okay? So, let's go with it. The first time you taste the Coca-Cola, you're saying, ugh, it's missing the Coke flavor. There's barely any in it. Okay? So if the taste is no soda flavor, that means it's unsaturated. Oops. That makes it unsaturated, guys. Yeah, that makes it unsaturated. In other words, you don't have enough syrup dissolved in the soda water to make the Coca-Cola you love. That's unsaturated. Okay? Now, how about when it is saturated? Well, if it is saturated, that means that's the maximum you can have in there for that temperature, and it tastes good. It tastes like the Coca-Cola you like, although come on, between you and I, Mexican Coca-Cola in a glass bottle, totally better, because in Mexico they use raw sugar in their Coca-Cola. If you did not know that, that's what makes it taste so different from the American Coca-Cola, because the American Coca-Cola uses refined sugar. I'm just saying, yo, chemistry in the real world, Cringe Master C once again brings it to you on your computer. All right. Any questions? You'll have to talk to me later. Okay. Now, what happens, on the other hand, you got your soda, you go in, and it tastes too sweet. Too much sugar. What's happening? It's what we call super saturated. In other words, there is more in there, and that's one word. There's more soda in there. There's more of that syrup in there that would normally be there. The normal is saturated. That's the maximum that should dissolve. If it's less than, okay, it's, unsaturated. Okay, it's unsaturated. Saturated is what you want. If it's too sugary, too sweet, it's super saturated. And that does happen. But unsaturated tastes gross because you don't really get the soda, right? The saturated is when you have the soda and you enjoy it. Super saturated, it tastes too sugary. It's, Okay, I think I've spent enough time crossing that one with you guys. Okay? So, dynamic equilibrium, okay? We talked about supersaturated there. A dynamic equilibrium, it's when disassociation and molecules coming back together occur at the same rate. I'm not so concerned about that, in all honesty. But the supersaturation, unsaturated, saturated is far more important to me. Now, here's an example where we have water and regular salt with some heat, and we end up getting sodium and chlorine broken up. They're surrounded by the water. Now, the equation does not show you that. See this arrow going back and forth? I whip my hair back and forth, I whip my hair back and forth. It's called an equilibrium, okay? So something is happening where the reaction's going forward and it's going backwards at the same time. Sorry, I don't have a real life example on that one with you guys, okay? I don't. Okay, so, hey, can we change how fast something dissolves? Why, yes. Yes, you can. All right, I got to check my timing here. 13:09. All right, we're winding down. Temperature, stirring, and surface area exposed to the solvent. Okay? Temperature, pretty straightforward. Okay? How does temperature affect solubility? It usually helps the solids and liquids dissolve. Remember, higher temperature, more heat, it's causing the molecules in there, because remember, they're vibrating, right? They're vibrating. Little kids, they're normally full of energy, right? But if you add extra energy like sugar, they're like, yeah, right? They get hyper. Well, that's kind of what's happening here with the temperature. If you're adding extra heat, the stuff that's getting dissolved is going to get dissolved faster. Okay? Adding heat is about the same as adding more reactant to it. Okay? Adding heat is like adding more reactant to it. Okay? So, how does it do it? When gases dissolve, they usually release heat. Heat is a product of the process. And that's when we get something called effervescence, the escape of a gas from a liquid gas solution. And once again, chemistry in the real world, whenever you open up your soda, whether it's a can or a bottle, and you pour it into a glass, and notice the bubbles are trying to escape, they're saying, I'm free, I'm free, I'm free, right? That's called effervescence. That's what it is. Okay? Oh. Now, I need to go back a little bit here because I wanted to show something to you guys. Stirring. Stirring also makes the process happen faster. The more you're stirring, the more you're getting things mixed up, right? Then you also have the surface area exposed to the solvent. Well, here's an interesting question. So if you got sugar in a, if you got here's sugar in a cube, right? And then here's sugar in powdered form. So you have a sugar cube and you have a powdered sugar. Okay? Now the question is, which one dissolves faster? If you put both in a glass of water, which one's actually going to dissolve faster? You can pause, and when you think about it, okay, and then when you're ready, unpause. And we're back. Did you say the cube would go and dissolve faster? If so, no, it's not. Powdered sugar is going to dissolve a lot faster. Why? Because the cube, you only got the surface there that's being affected, right? You got all that sugar inside the cube that's not being exposed as quickly, whereas powdered sugar, it's tiny little pieces, so you get a lot more surface area. Okay? If you notice, powder, when they sell chocolate drink mix in powdered form, you notice it's in a powdered form, it's not in a cube. That's because the powdered form is a whole lot easier to dissolve. Okay? And guys, with that, I am done here for part 2 of chapter 12, part A. A lot of main concepts there. Okay? But you're going to be great. You're going to know it. Okay? Some really cool ideas, but you also see it in your everyday life. And remember, God made all this stuff up just so man can try to figure it out. All right, I'll catch you guys on the flip side.